Thank you for joining us this afternoon for the Digital Engineering and Advanced Manufacturing Mission Domain Engagement. I'm Rich Tempalski, the Department of the Air Force's Chief Modeling and Simulation Officer and Chief of Digital Engineering and AQ. I'm pleased to share the virtual stage today with some of the industry's most remarkable technical innovators. They're from companies that are leading the world in research and development of capabilities and are really revolutionizing the way we think and fight in every mission domain. Now, how I'm going to be setting up this panel up is I'm going to be going through and give a quick introduction of each of our distinguished panel members. After my introduction, each of them will have the stick for opening remarks and what they bring to digital engineering and advanced manufacturing. This will be followed by having them answer some questions we prepared for them. And for the audience, if you have questions, please don't use the chat. Instead, use the question and answer box at the bottom of your screen. Now, first up is going to be Paul Ferraro. Paul is Vice President of Air Power at Raytheon Missiles and Defense. The group he leads provides command and control and sensor power to the Air Force. Paul has over 25 years of leadership experience, including Vice President of Sea Power Capabilities and Vice President of Advanced Technology Programs. He is a graduate of University of Massachusetts, Amherst, with a bachelor's and master's in electrical and electronic engineering and a master's in business administration and management from Boston University. Welcome, Paul. Would you care to give us some opening remarks?
Apologize. Thanks, Rich. Thanks for having me this morning, and I appreciate the opportunity to speak to the audience and be part of this group, certainly. I think it goes without saying, and we've heard this over the last few days as part of AFA, the need to adopt digital engineering in all its forms is not only a nice to have by any stretch, it's an imperative. It's an imperative to us as industry partners to remain competitive, but more importantly, it's an imperative to design and deliver the weapon systems that we do and make this available to the warfighter at a much more rapid pace. Clearly, our adversaries are advancing their capability, and as they do so, it's eroding our technological edge, and we need to respond to that in earnest. And the advent of digital engineering and model-based engineering, and furthering the instantiation of those processes, tools, and techniques is absolutely critical to us keeping pace with our adversaries. This year in Raytheon Missiles and Defense, the business that I'm part of within Raytheon Technologies, the investments that we're making in digital engineering and furthering the maturity of the processes that will go hand in hand with digital engineering and the tools and resources that it provides, it's going to be a keen focus for us. It certainly is at the Raytheon technology level as well. I'm sure Matt will speak to that in his segments. We're still learning as a company. Raytheon Technologies, as you know, we underwent a merger earlier part of last year, and we had a number of synergy targets and opportunities that we saw at that point with our new corporation. And as we get to know each other even better and focus on projects and capabilities such as digital engineering, we're finding that we have pockets of expertise across our company that we didn't even realize initially, and we're bringing those to bear as well. As we identify those opportunities, I think that's opportunities not only for us as industry partners, but more importantly, really present some opportunities for us to deliver some capabilities at a much greater pace and much lower cost to our warfighters. So something that's very exciting for us and looking forward to be part of.
Thanks, Paul. Next, we have Andy Kuhn from Aerojet Rocketdyne. Andy is the Enterprise Digital Engineering Deputy at Aerojet Rocketdyne, where he has served in engineering assignments ranging from Senior Systems Engineer to Manufacturing Engineering Manager at Stennis Space Center. His background also includes automotive, powertrain, and gas turbine engine development from when he worked at General Motors and United Technologies. He has a bachelor's in electrical engineering from Purdue, along with a master's of science in quality systems management and continuous improvement. Thanks for joining us today, Andy. Anything you'd like to add from an opening remark perspective?
Certainly. Thanks, Richard. Certainly wonderful to be on with these esteemed colleagues today. And, you know, I watched the DE panel yesterday with great interest, and there's a lot of great takeaways for folks that got to be part of that. And what's interesting is I think as you see the folks represented here, we're propulsion providers for the most part. So I think we have similar challenges in the industry with this digital transformation, in that we're supplying, for the most part, multiple prime contractors for propulsion products. So, you know, some of our evolutionary steps along the way as we join in with the DoD strategy for digital transformation is how to look forward to those opportunities and concerns that come along together as this journey takes place in the marketplace. So, you know, we are constantly actively seeking collaboration with our prime contractor and government customers to seek out what are the most important capabilities on our journey of maturation in the digital transformation, to help establish tactical approaches, milestones, and, you know, kind of benchmarking what the Air Force has done with AFWERX, partnering with our primes on how can we establish pilot projects to mature our ability to bring the warfighter iterative design capabilities at a much faster pace than we've had in our traditional acquisition processes. So we see that area of collaboration is critical to our future path. We see some challenges related to intellectual property protection along the way, and that's been brought up in other panels so far on this symposium. We see an opportunity, however, though, with the new industry standards and open architectures that the DoD is trying to impress upon the marketplace. We do have some concerns in the sausage making process to actually transform conceptual designs into real hardware related to specific mandated tool usage and methodologies as we supply multiple primes in the market. So we have some concern there. So what we really are looking for, and I know the DoD has, as part of their lines of effort in the digital campaign, have been addressing the ability to create unambiguous, timely digital engineering deliverable expectations. And we're really hoping to partner with everyone along that journey. It's good for me today. Thanks, Richard.
Thanks, Andy. Some great points there. Also on the panel is we welcome Dr. John Matlick from Rolls-Royce Corporation. John is the Engineering Digital Transformation Lead for Rolls-Royce Corporation Defense Business, where he leads a collaborative, multi-function integrated product team. This IPT is responsible for developing, verifying, validating, and implementing new DE capability. He's been working there for over 16 years, holds a bachelor's, master's, and a doctorate in aeronautical and astronautical engineering from Purdue University. Thanks for coming, John. And now the floor is yours for remarks.
Thank you, Richard. Also I'm very honored to be a part of this distinguished panel and very excited about the discussion that we have today, in part because of the opportunity for the collaboration that we have to address. You know, definitely, if you go back to Systems Engineering 101, failure occurs at the interfaces, and that's also where digital engineering actually provides a substantial amount of benefit. So being able to manage those interfaces is very important, not just within our own companies, but across the larger enterprise. So, you know, I'm excited to be here in part just because of that context of collaboration. Secondly, it's very exciting to have the discussions about what does it look like for a business model built on agility. In particular, as we're talking through some of the new opportunities coming forward, things around attritable and how that may transition the way that we operate. We have very strong historical experience in business models and sustainment. So what does it look like as we transition and look at agile kind of responses as well as business models around sustainment? So excited to talk and explore a little bit about how digital engineering is an enabler for that. Trust. I think we all have a great discussion in this whole landscape of digital engineering around trust of models, with no model right, some of them being useful. And, you know, understanding how do we establish a level of trust in the models themselves, but also a trust in the use of those models, where we move towards things like authoritative sources of truth across the whole life cycle. How do we know that the models and the data and the simulation results that we're using, not just across the life cycle within an organization, but across organizations, we have the confidence there. And then just finally, a lot of what we have in terms of agility is paced by certification. So there's some pretty exciting opportunities that we can opportunity to talk about maybe here around attritable. And as we're getting towards things that don't involve human beings, you know, is there a possibility to better leverage data models and simulation in a way that accelerates from an agility perspective through certification and some of those new opportunities? So just a few initial points and topics that I'd be real excited to unpack. And thank you for having me.
Thanks again, John. Our next panelist is Matt Tyshar. He's from GATORWORKS, Pratt & Whitney. Matt is the Executive Director and Program Chief Engineer of Pratt & Whitney GATORWORKS, a division which is set up to deliver innovative new technologies, systems, and services through agile development and rapid prototyping. He's been doing this for over 14 years and holds a master's in mechanical engineering from the University of Connecticut and a master's in management science and engineering from Stanford University. Matt, is there anything that you'd like to add?
Yeah, good afternoon, and reiterating the thanks for the honor of being a part of this. First off, Pratt & Whitney celebrated 95 years last year, and we're really, truly humbled and honored to be the propulsion provider on our top priority programs in the U.S. Air Force, the F-35, KC-46, and the B-21 bomber. All of us have seen a really significant industry discussion around this trinity. I can tell you from a propulsion standpoint and point of view, it's about speed, it's about agility, but it's also about speed of relevance. We really believe there's an existential threat within propulsion that if we don't figure out how to speed up the clock time and deliver these needed capabilities into the hands of our warfighters, we're going to get left behind. And obviously that's not someplace we want to be. When we talk about digital, I think it is worthwhile to start from recognizing that strong foundation that I know all of us have in digital capability. Often the first time you start talking to someone about digital transformation, they're like, wait, don't we already do a lot of that already? And we do, of course. We depend utterly on cutting edge tools and methods and computing to do what we do every single day. But the real potential, as you've heard, is integration, and it's unlocking the new speeds, new cost savings, improving the quality of our products by reducing handoffs and leveraging that new technology and automation, machine learning to really attack at our interfaces, not just internally, but then of course externally, which you've heard in opening comments. We really are recognizing, in particular with model-based systems engineering, that linkage with our weapon system contractors really is very critical and is a real opportunity for us to be able to provide winning propulsions on relevant timelines. But it's not just external to platform providers, but also external, but within, like, for example, the Raytheon company, collaborating with our sister company Collins on 6th generation power thermal management systems, or as was mentioned by Paul in his opening comments, opening up new capabilities and maybe new ways of thinking about propulsion through some of the organic or native OA capability within Raytheon. And digital thread, though, we get gravitate toward our development and like the beginning of programs, because that's a real fun place to be with an engineer. But really, there's a very strong focus here in Pratt & Whitney also on sustainment and sustainment costs. We're very proud to be the only propulsion provider of our 5th-gen fleets. We have a burgeoning new commercial fleet with their geared turbofan product. Both of those platforms are extremely data rich. The amount of data that comes off every single flight from both those platforms is really mind-blowing to where we were even 10 years ago. So in that pyramid of capability, it starts with that advanced sensor suite that ends up in knowledge to guide decisions. Every single day we're pulling in massive amounts of data, processing it, sorting it, doing analytics, applying machine learning to it. I mean, it's happening right this very second as we're on this call, and we're using that data in new ways. But I think looking forward, the real key is going to be what I call predictive MRO. So it's not about getting the data for data's sake, but it's what we do with it in the future. In closing, it's an exciting time in our industry. Normally, we're characterized by many small evolutions that, in time, really do absolutely amazing things. But I think we're really talking about potentially revolutionary new capabilities. That's really exciting. And innovation at Pratt & Whitney, it's not just in our products, but it's how we do business, and that's one of the key tenets of GATORWORKS. And we're looking forward to what's to come.
Oh, thanks for the remarks, Matt, and thank you all. Once again, I am pleased to be able to moderate this event with such a distinguished panel. Moving on to the questions, my first question is going to be for the entire panel. And it is, can you each provide an overview of how you are incorporating digital engineering practices into your company and how this will benefit the DoD? Now let's start that with GATORWORKS. Matt, you're up.
Yeah, sure thing. So I think a lot of the responses to that were in those opening comments. So, we look at digital engineering and its integration. That's not just model-based systems engineering, but how we tie our tools together. The automation from an engineering standpoint, is really where I think a lot of the opportunity comes for speed. It's a little embarrassing, but I feel comfortable saying it because I'm sure I'll get backed up that if you really dive and go into a lot of our processes here, you'll find engineers that are transcribing stuff out of Excel into text files and then manually showing them into models. And it's really hard to go fast when that's one of your modes of operation. So it seems prosaic and pragmatic, but that's a real opportunity for us. I talked a little bit about some of the sustainment opportunities in really opening up. Right now, I'd say it's a lot of basic analytics, upfront stuff, but really opening up to understand what's out there in artificial intelligence and machine learning. I'd say we've dabbled in that and we've got that running, but with the absolutely data-rich streams we have coming off these jets, that's going to be a real place of future focus.
All right. How about things at Rolls-Royce, John?
So yeah, how does digital engineering practices get embedded here? So we've done digital engineering, digital capabilities, or may have been tagged differently, has been something that's lived in the civil and the corporate landscape for a while. And so there's an awful lot of lessons learned from that. One of those key lessons learned we found in terms of how we've embedded it into practice to make sure we're focusing on value. Identifying specific program risk, costs, and needs to figure out where we really want to focus efforts, and then bring the digital capability and solutions to address those needs, so that a lot of that capability which exists. There's a really good quote from Colonel Paul Harmer early on in the journey that was shared around, said, the future is now, but it's not evenly distributed. So rather than trying to do wholesale integration of digital engineering across our entire business all at once, we've actually been very targeted and focused at areas of greatest business value and priority. And that it includes the area where the culture and the championship within different parts of the programs is there to receive it. And as we start demonstrating value, you start proving out, and then it kind of snowballs and grows and people understand tangibly what that value is. So a couple things. One, that value-focused approach can be applied to both new programs that are born digital, but it also can be applied to legacy programs where there's significant value in the application of the digital technologies. In fact, one of our key tenets is that legacy programs does play a critical role in our transformation, because that's where a lot of the data and the experience is. So when you want to do an anchoring and a validation of capabilities, leveraging what is already out there in the field, how people are using things, how things are being made, being able to move manufacturing and services left, it's very important to kind of leverage that information. So that approach, that value-focused approach for us, has actually enabled realization of benefit for the two of the main DoD mission objectives around, first, agility and acquisition. So how do you get cost, speed, and risk down early on, but also being able to reduce cost and increase availability within sustainment in the banner of things like CBM plus. So I think, from a Rolls-Royce perspective, just a focus on value approach has actually been very beneficial to us.
Thanks. Andy, does Aerojet Rocketdyne have any additional practices?
I'm very sorry, Richard, but I had a little audio glitch there. Could you repeat the question?
Yeah, absolutely. The first question is, can you each provide an overview of how you are incorporating digital engineering practices into your company and how this will benefit the DoD?
Yes, certainly. Okay, I thought you were asking me a separate question. Sorry, Richard. Yeah, absolutely. So, I really like to follow on from Matt and John in that area. And maybe I'll take us back to a quote from J.G. Miller yesterday. I really liked his title. He said, "Yeah, I'm the chief engineer for the ET-7A, but I'm also the chief cultural officer for the company." So, or for the project at least. So, that's really a part. We all think we have dual efforts here. Of course, we're involved with maturing our internal processes and our tool sets in order to, I think Matt mentioned it, pull down the silos and maybe some of the work practices that we've got some very capable subject matter expertise within our enterprise as well, but you got some folks that are used to doing things the way they've always done them. So it's that cultural transformation is just as important as the technical aspect of that to bring the silos down internally. So what we say success looks like, we're actually share a little inside baseball. We're following the NCOSI model-based capability matrix and using it not just as an assessment tool for our internal process maturity, but we're also using it as a planning tool to progress through the multiple stages that's defined by that tool set. So we're leveraging, especially by the fact that NCOSI is working closely with DoD as they develop that strategy. We're following that for our primary internal perspective to grow the processes. But we're also looking to mature our interfaces with our primes and to the US government. We have a unique situation with very low volumes for both our defense and space businesses. Really see the digital transformation as an opportunity to leverage what higher volume industry has always benefited from with lots of data, whether it be from sample data using quality management systems. We're now going to be able, through the digital thread and assigning pedigree for those authoritative sources of truth from our modeling environment, from machine learning on the floor, and from applying artificial intelligence to our heritage data on multiple heritage programs. We really see this transformation to grow internally and expand the interfaces as we supply multiple primes in the marketplace. One of our unique aspects is for future weapon systems, for instance, that area of our defense business, we will be supporting multiple primes and having to firewall our own systems and personnel for concept and development programs coming up even very soon this year. And so that ability to build our digital infrastructure at the same time maintaining firewall IP protection for our primes is a unique, complex challenge as well. But we really see that as a overall advantage to the government customer ultimately, because now the primes that end up winning down selects will be already established in the GRAs, and then our content will easily flow into that and lead to the agile iterative design activities that we anticipate early, everything from the early life cycle and concept all the way through sustainment.
Paul, you're a leader in development for air power. How do you drive digital engineering for Raytheon?
Well, Rich, I think like all of us, we've all been using tools and models and elements of what we're now calling digital engineering or digital technology for years. And I think what we're looking at now is really in a much more comprehensive way, embracing the full potential of that. Really generating these singular databases and singular authoritative sources of truth that span the entire life cycle of a design, development, fielding, and sustainment of the programs and capabilities that we collectively and individually deliver. Digital technology has the ability to significantly increase the acquisition process. As we continue to mature our digital thread, we anticipate that we can shorten that cycle by as much as 30%. And as well as have a much more responsive and robust design cycle and process, responding to information that we learn in one element of our design programs and fold it into others in a much more complete and comprehensive way than has ever been possible in the past. So that certainly speaks to the value of speed and agility, and we're trying to incorporate these tools and, more importantly, the processes that these tools enable in a much more complete fashion across all of our programs, irrespective of whether they're new program starts or perhaps some legacy programs. But I think John raised a couple of very good points when he spoke to trust, collaboration, and ultimately the value that this brings and how digital technology brings value. This is a very, very different cultural shift, if you will, in terms of trust and collaboration. The data that we produce, and as we supply that data to this authoritative source of truth, we really need to be very open as a team, both as industry partners and with our government counterparts, that everybody now has access to that data real time. We're sharing the work that's in process. And that's a different mindset for us. Not all the problems are resolved at any given point in time, and we're collaboratively working together to resolve them in the most expeditious and comprehensive way we can. Similarly, I think to really derive the most value out of these processes, these tools, processes, and resources need to be extended seamlessly through our supply base. To bring our partners in as part of our team, support them as prime. Some of our smaller subcontractors and partners may not have the means to establish the infrastructure necessary to stand up digital engineering and digital technology infrastructure to its fullest. We need to support them in their ability to do so that they do operate very seamlessly as an extension of the prime contractor's internal resources. So that's it. That's a shift as well, and I think that will very materially improve the collaboration that we have across these very complex teams. And the last point I'll mention, and again, John brought this up as well, is where do we derive value across the digital thread? Certainly the vision is to have a contiguous digital thread from the earliest phases of a design all the way through detailed design, production, fielding, and sustainment. But that doesn't need to be fully in place to derive value. With some of our legacy programs, they're very rich in data. They provide a great amount of insight to how these programs operate in their intended environment. And we can take that data from fielded systems and incorporate that into other programs in its earlier design phases and really focus where is it that we mature the digital thread, irrespective of where a particular program is along its design cycle or life cycle, and derive significant value in pieces of a complete digital thread, and then continue to build out the digital thread in that fashion.
Thanks, Paul. And thanks, panelists. We appreciate all those answers. For the next set of questions, we're going to be asking the panelists individually. Now, Paul, you're up again. This question is for you. New start programs have an advantage of being born digital. What can be done to assist existing programs to transform digitally?
Well, as I mentioned, Rich, I think the advent or the incorporation of a more comprehensive digital thread techniques and processes can be applied at almost any phase of a program. We have a program that we're embarked on right now called LRSO, or Long Range Standoff Weapon System. And we're incorporating the tools, techniques, and processes of digital engineering as completely as we can on that program. And it has truly paid dividends. I'll give you an example. So in our software development efforts on this program, we developed the software that resides on this missile and essentially allows the missile to operate as intended. We've built our models that include most every major component of that missile. Okay, so we can, with great confidence, model the behavior of the missile, how these interfaces operate, how the missile operates in its intended environment, and then we have an ops analysis model that really shows the environment in which this missile will fly, and the obstacles and impediments and characteristics that it will need to have in order to properly perform its mission. Almost on a daily basis, our software team and systems team builds a new load of software. They incorporate that software build into our model. Each night we fly upwards of 6 million virtual miles with this digital model of our missile. Fly it through modeled adversarial terrain and circumstances. Assess how the model performs in terms of survivability, lethality, or any other salient parameter of that weapon system. Digest the outcome of this digital or virtual flight path along with the customer, who again has access to this data in real time. Make adjustments that are necessary to improve the overall performance of the model. Incorporate those adjustments into yet another software build and rerun that digital model again the following evening. It is such a much more robust design process that we have because of this, let alone the fact that clearly if we didn't have this virtual capability, we wouldn't be flying this missile under our adversarial conditions as we do in the simulated model. The next piece is that from a digital environment perspective on this program is one of the gating items typically with software development and then software to hardware integration is the availability of the hardware itself. Because we've developed such a robust model of the hardware, we can essentially virtually integrate this software with the hardware well before the hardware is made available to the software and systems and integration and test team. That again is reducing risk, and in so doing, taking years off the development program and certainly reducing risk along the way. So we use that to its fullest extent possible. And then ultimately, when we do have the opportunity to fly this system, we'll incorporate the data that we gathered through those flight tests back into the model, continue to build the robustness of the model and anchor the model with real world data and establish the credibility of that model so we can support this system for many, many years into the future.
Yeah, thanks again, Paul. Next question is for Dr. Matlik. John, one of the precepts of the Air Force digital transformation strategy is authoritative virtualization. How are you approaching an authoritative source of truth or ASOT in your programs?
Yeah, thanks, Richard. So Paul actually made some good comments on the authoritative source of truth up front and the impact of the supply chain. And I think, I want to unpack that a little bit. First off, from what it means from an individual OEM, Rolls-Royce perspective, and then what does it look like when you start trying to utilize that across the supply chain. Historically, we and others have leveraged larger executive systems like product lifecycle management, software solutions platforms, ERP solutions, manufacturing execution systems, sustainment platforms, and some smaller bespoke solutions even in order to house our data and our models across the life cycle of the product. Though that does allow you to capture and version control data and models within those systems, it is not actually ideal for the solution and realizing the vision for what the DoD digital engineering strategy has for the results in significant inefficiencies. In the past, we've seen up to 30% of your time spent looking for data and then integrating that manually in order to make the decision that you're after. And it's led to a lot of confusion also about which system sees itself as boss, right? Which is the authoritative system. So today, we're being much more definitive about which platform owns what data and are pursuing secure cloud solutions and domain-driven design approaches to kind of automate the access to data across platforms so that it can be safely connected to the other data. That's obviously underpinned by a data strategy and architecture and standards. It is enabled by agile software development and DevSecOps best practices as you kind of connect and go through that process of automation. This also allows the integration of, and we just have a really good parallel workshop going on right now on the integrated development environment, but it allows you to integrate the model-based engineering landscape, model-based system engineering, PLM, analysis and visualization. An important piece about that for the rest of the lifecycle also goes into all of your manufacturing execution systems, the supply chain, and others. So it builds that beautiful progression of integration to automation and then enabling collaboration across the supply chain. I think that works really great for an organization that owns all of the IP and the data. Paul referenced this a little bit earlier. However, several key challenges come in when you need to integrate and collaborate now outside of your organization across the supply chain. I mean, these are common questions that come up. How do you respect and protect yours and others' IP? How do you ensure cybersecurity is maintained across all those parties and organizations? From a Rolls-Royce example, we have 1,100 North American suppliers. Almost none of them have the same IT kit. They're all varying levels of maturity in terms of digital. And they don't just supply us. So when you get to things like digital standards, imagine having all of us, including the Air Force, tackling these small business folks and trying to deal with standards and requests for information in many different formats. Sometimes a given organization may ask multiple formats from just that one organization. So we do need to consider the supply chain. Another aspect I mentioned already is the trust in models, not just the trust of the models themselves, but the use of those. As you establish an authoritative source of truth, and now you're consuming those models across the supply chain, how do you clarify for that model where it's applicable? And making sure that as when people are using them later on in different parts, not just maybe inside your given organization, but outside, how do you make sure that it's not going to be used in the wrong environment and in an invalid landscape? So very important. All that being said, there is no turnkey solution today for the type of collaboration that will realize a full enterprise management across the full life cycle and supply chain for an enduring authoritative source of truth. So how do we tackle that, right? So from a Rolls-Royce perspective, we've been getting very specific and continuing to run tangible pilots, similar to the way that the U.S. Air Force digital campaign is, right? 10 Pathfinder projects or tracers, if you want to use kind of agile software language, in order to really collaboratively experiment and learn what works, learn by doing, and learn by collaborating. And it's not just technical, it's also business aspects of that. So this is where I believe that the U.S. Air Force and industry could benefit significantly from an appropriate consortium or consortiums to address these and other challenges, to help address those risks, and to move toward realization of the full benefit of an authoritative virtualization and all that that has to offer. So some initial opening comments on that.
Oh, thanks, John. Andy, this next one is for you. As the Air Force and Space Force work to shape the integration of digital engineering practices into future acquisition efforts, how is industry partnering with the government to bring this vision to life?
That's a great question, Richard. And, several of the panelists and myself in earlier comments have addressed that somewhat, but, related to things like the architecture, IT architecture problems and the supply chain problems that John just brought up, with ourselves being a major supplier and dealing with some of the same subs that my esteemed colleagues here are dealing with as well. There's one significant effort that the government, I think, is beginning to address, and we're trying to help with that, is to how do you bring the supply base up to speed? In our business, for rocket, both solid and liquid rocket components, we may have single suppliers or, at best 2 or 3, and our volumes are so low that it's hard to keep them in the market anyway. So making the digital transformation as transparent and as simple as possible for those key elements of supply chain is going to be crucial. So we're trying to partner with them as well and bring them on board in a way where they can, some of them may still only have a 2D drawing environment, for instance. They may be well down in the technology chain. We need to be able to help them bring up to create simplified model activity that we can pull in at the fidelity that's required in order to meet mission success as defined for the digital landscape. So bringing the supply chain along is key to the success and maintaining the health of that supply chain, as we need to maintain US-based capabilities with the adversaries that are also seeking to mature as well. So that's a key part of the US infrastructure in that regard. Another area where we're working is this collaboration that's been brought up. We're seeking to mature the industry consortiums, such as the OSLC standards for data open architectures, so that at the same time we're building and maintaining cybersecurity, which has been brought up, so API development and potential use of blockchain to supply secure connectivity to the elements of the program that need it. Same time we're locking down cybersecurity to keep the adversaries out, we also need to develop the open standards so that the supply chain base can easily plug in, add their value where needed, and not endanger the cybersecurity element of the intellectual property and government security concerns that could come about from these open architectures.
Yeah, thanks, Andy. Matt, this one is for you. Technology enabling today's digital transformation is complemented by advances in manufacturing technology. What do you see as the benefits to the integration of digital engineering and advanced manufacturing technologies into your company's operations?
Yeah, I really like this question, Richard, because it touches on something that John mentioned earlier about, when we talk about digital, we have to always make sure we're trying to find the North Star of the why. So at the beginning of the conversation is what's the value, right? I mean, doing digital for digital's sake is cool, but I think you got to start with the why. And, in this case, it's a really easy linkage to make. You start talking about making real metal. It's our ability to deliver more quality parts more safely, more quickly, and at lower cost. So it's a really simple value statement. When I think of the question, I think of it in 2 segments. The first one I'd say is maybe the more organic or maybe disaggregated examples of digital and advanced manufacturing. These are teams solving what I'd say are like tactical problems, maybe using additive technology with digital. So, if we have a machining error on a long lead forging or casting on a development program, we could either choose to absorb a multi-month delay as we go try to make a new part, Or, and this is a real example from 2 weeks ago in my world, we'll send a model over to a trusted supplier, and then later that week they have a replacement printed for us to go take a look at and evaluate. Or we're on the shop floor trying to build a development motor or a prototype, but a piece of tooling is not quite right. We adjust the model, reprint it, back up and running the next morning. There's also potential for product costs, so in particular on attritable or expendable programs where perhaps some of the challenges involved with additive are a little bit easier to digest. Unitizing complex assemblies is really a ripe area for opportunity. Or you open up new capabilities. So some of the advanced additive heat exchanger work that our sister company Collins is doing and that we of course are using, really exciting new capability that frankly would not be achievable. The design times would not be achievable any other way besides working in a highly digitized environment, releasing digital definition, printing, and then evaluating, and then doing it over and over again. So those are some like kind of very tactical, meaty ones. The second category I really think about are the more systemic or broader reaching. So, there's a nice combination of digital and advanced manufacturing, that Venn diagram, and Industry 4.0. And this is something that people like in Pratt Whitney, like in Shane Eddy and Dave Perry have taken really strong and powerful leadership positions. This combines a bunch of different things, whether it's model-based definition, manufacturing, inspection, connected factories, with sensors, Internet of Things, and and more importantly, the analytical engines that plug into all that data. Deep automation, so closed door machining, advanced step changes in advanced robotics, at least for aerospace, and digital inspection, and then even things like digital workforce. And I was talking with Dave Perry about this, and he brought up an example of there are some people on the shop floor that if a machine stops running, they literally need to know that machine stopped running within seconds. So and if they're using their hands all day, having a digital watch that lets them know the machine stopped running actually is not just a gimmick. That's actually a really important thing. So it's a combination of a bunch of things. We're, of course, at Pratt Whitney, we're driving this transformation to our existing facilities. We'll have, as a proof point here, over 3,000 of our Pratt Whitney machines all connected by 2023. And each machine that's plugged in makes that analytical engine smarter and us better. But we're also taking advantage of a greenfield opportunity that there's been some recent press about, a new casting facility in Asheville. This facility from day one is really going to be a concentration of a lot of those Industry 4.0 Venn diagram between digital and advanced manufacturing day one, and it will become a template for future facilities. But I did want to close here and kind of foot stomp a point that John, Paul, and Andy all brought up. The supply chains are really big focus of this. So that last example was very pure vertical integration for Pratt & Whitney. So something that's really highly controllable. And we have a lot of trusted partners in the supply chain that are also pretty far up on plane and drafting with us. But it takes a very broad supply chain to make aerospace work. And it doesn't take too far looking to find those shops that are still using 2D drawings, finding those shops that would need a big lift and really basic technology to be able to even receive and communicate in this world that we're portraying in the future. So a big focus area for everyone involved, but it's something that definitely needs to be solved in the future.
Yeah, thanks, Matt. Panelists, we're doing fantastic on time right now. And if you watched this yesterday, you know where we're going to be heading. And where I'm going to go is literally what I did yesterday. And that's going to a sort of a lightning round where each of you has about 60 seconds to give us your thoughts on the question that we're going to be asking. And it's going to be the same question for each of you. And I'll call you out when it's your turn. So the first question to the panel is, how does data architecture fit into your digital transformation? And Andy, how about you take that first?
Sure, Richard. So yeah, we touched on that somewhat, and data architecture is foundational for particularly a middle-sized company such as we are. We're not the big gorilla prime, and so our architecture investments have to be very targeted. So, for instance, as we're developing a subject matter expertise community of practitioners, we have to settle on one or two tool sets, right, that we can develop that expertise in. So the ability to transform model content, whether they be physical, behavioral, or analytical, descriptive type models, they need to be able to be transformed. So the architecture needs to support, and we see that third-party software providers are really starting to meet the market need there. We're actually creating, I think, a new market with this Industry 4.0 that Matt brought up in the marketplace to supply those transformations. We need to minimize human intervention to create the value of these models that can be transported to other modeling systems and methodologies. So that's a key part of infrastructure and architecture that, and as I mentioned before, to keep the cybersecurity element simultaneously as we create open systems are going to be key to removing human intervention, assigning a pure pedigreed authoritative source of truth as these iterations happen in the design cycle and all the way through sustainment. So everyone knows they're working, can trust they're working with the authoritative source of truth that has high fidelity based on the authorship of that data. I think that's about 60 seconds.
Yeah, that's right on the money. Matt, how does data architecture fit into your digital transformation?
Yeah, well, I'll echo Andy's comment that it's kind of it's really truly at the foundation, certainly at least some of the elements of digital engineering. The reference architecture for the system model, the data, the interfaces, the governance processes. Even we heard some discussion on cybersecurity, interoperability. I think Dr. Roper at one point was talking about a government-like delivered reference architecture for everybody to plug into. That that might be a bridge too far. But I think that it does underscore that it's got to be a very early focus, not just in industry, but in that industry and government partnership to address that sort of kind of key first step question.
All right, thanks, Matt. Paul, how does data architecture fit into your digital transformation?
Yeah, I think a lot of the comments that have already been made are absolutely spot on. I mean, let's be honest with ourselves. The cost of buying, developing, and installing the infrastructure necessary to support digital technology or digital engineering is substantial, and not every partner that needs to play a part of this can afford that capital investment, let alone the training and sustainment of it. So having data architecture defined in such a way that we can minimize that cost of participation and really be as inclusive as we can and ensure that we're sharing data in a very cost-effective way, in a well-defined way, while maintaining the cybersecurity necessary to maintain the fidelity and security of these models is going to be critical. I look for signs of when we've quote unquote when we're getting it. When we're really instantiating digital engineering and all of its forms and really using it to extract value. And I think it comes in stages. As I mentioned, certainly we've all been using models for years and its various design elements and modeling our systems. Now we're talking about bringing those models together and sharing a common source of truth within those models in a way that's much more comprehensive than in the past. And one of the signs I'm looking for is, is that sharing of information, is the sharing of processes and trust and collaboration extending to our supply base, to all of our partners? Is it being shared commonly across even our corporations? And I think just in preparation for today's session, Matt and I have already come up with ideas of where we can share information across Raytheon Technologies in a much more seamless way. And then certainly with the customer, real-time data sharing and being able to do that in an efficient and effective way without undue burden of the cost of the infrastructure associated with doing that is going to be critical. So I think it's getting the data architecture right, getting it understood, and designing it in such a way that we can minimize the infrastructure and maintenance cost of getting all this participation is going to be critical.
Yeah, excellent. And John, how does data architecture fit into your digital transformation?
And again, it's a lot of reflecting a lot of what has been said so far,
Right.
but we say it's nucleus. It's kind of at the nucleus of our digital transformation. And then just a couple more points to just add out. First off is just, the valuing of information and data. This almost is the new oil, right? We've heard that said several times in several different contexts. And as you get from data to information to knowledge and wisdom to informed decisions, it really enables a lot of that agility. So, that architecture is really important to enable the automation, to enable the use of machine learning, artificial intelligence tools. It also, fundamentally, we're looking at the larger system. And I've hammered this a few times now, but from the supply chain landscape, got a lot of work going on in industry whether it be AIA or others that are looking at what is that data and digital interoperability standards? What do those look like? How do we better connect across the broader landscape? How do we address that? And then how do we connect into the reference architectures that we're all kind of building out? And the government reference architecture, what's the relevance? How do we connect in there? So I think, this is something that we need to continue to discuss as a community again, not just within our own organizations, and finish landing. What is interoperability? What does our data architecture need to look like for the enterprise? And that's an important discussion we need to have.
Thanks. Now we do have some time for some additional questions. And one of these questions is one that keeps coming up time and time again. And this one deals along the line of culture and training. So the question itself is, people and their interconnectivity are as important to digital engineering as the architecture. What has taken place in the training and culture development at your company to move the workforce into digital? I'm going to start off with you, Matt.
Yeah, that's a great question. I think when I think about that question, first I'll mention that there's a tailwind of a lot of our younger engineers and younger talent coming in. So we talk about digital as a new way of doing business. Folks that have joined our company, say in the past 5 or so years, that's just normal for them. This is not like a new shift to something different. They're very prepared and willing, quite frankly, to be engaged. I also would say that, Dr. Roper described it well, where he described a lot of this stuff as allowing engineers to be engineers. So a lot of digital engineering is about reducing that friction that I mentioned in opening comments. And that's great, because the more friction that you take out of my life, the easier my job is, the more time I could spend doing the real fun stuff that each of us on the panel does. So that is another tailwind. With that said, it is a culture change in many respects, especially as you start perhaps trusting models more or becoming more integrated, breaking down those silos. And within Pratt & Whitney and GATORWORKS, it's really being deliberate about the change management part of this. So it's an established sort of science and approach, but it's not incredibly complex. But if you don't be deliberate about it and seek to find that buy-in, find that 10% to help make the change happen, it won't happen. And that that's kind of a hard truth of large corporations. So I think those kind of wrap up my comments.
All right, John, you're up. What has taken place in the training and culture development at your company to move the workforce into digital?
So touching on the training and the awareness piece, purposing to target training and awareness from the executive suite down to practitioners across a whole number of things, right? Not just establishing a systems thinking mindset, training out hundreds on MBSE, leveraging it. We have a digital academy that targets behaviors. Also, when you start thinking about agile behaviors and operations, what does that look like? Because people make us agile. I think you just mentioned that before. And so connecting the people into that landscape, and how do you not just give tools, but also help encourage the behaviors that enable and unlock that. And then also a tangible example for, we leverage a digital enterprise exhibit that actually talks through the life cycle for how digital engineering is relevant and delivers value to the customer, to the programs at different parts of the life cycle, where you can have folks come in and engage in those, walk through the examples, and it's pretty powerful context. The last thing I would say, and this is, I can't underscore this enough, learn by doing. Fully understanding this full landscape by individuals is not possible. So you really need to get your hands in and get them dirty. So across our internal life cycle, we have internally, I think like many others do, our software factory, right? So our version of Kessel Run, being able to help educate and deploy the next folks of coders, the agile software development workforce. We have an advanced visualization lab, which allows us to do rapid, low-cost prototyping. And you can do that very nicely in a virtual environment, particularly in the context we've learned from COVID, where you have to be able to do that remotely. Leveraging remote solutions has been pretty powerful on that front as well. And then finally, we have something called the garage, because you do connect physical assets to the virtual models and the realities. Our garage gives folks the opportunity to get their hands on things like additive manufacturing experiences, agile ways of modeling and working, and connecting the physical and the sensors with the virtual. in order to get at understanding what that really means and what are some of the issues and challenges right that. So those are things that we put in, things that make it hands-on and learn by doing inside Rolls-Royce.
Thanks, John. Andy, what has taken place in the training and culture development at your company to move the workforce into digital?
Yeah, I was at Aerojet Rocketdyne. I was going to absolutely concur with my colleagues so far on that. And I wanted to take, maybe because I know our time was limited, take a little bit different aspect of it, because John introduced a topic about everything from executive leadership on down. And I highly suspect that all our respective companies still have, the purse strings are still held by the program management office. So I was going to try to pick up on a theme maybe from the session yesterday on the $10 widget. So when you look at how do you sell digital engineering to a new program that maybe is not as aware as we are in the technical community about what this really brings value for. Sometimes you talk about how can I take a couple of dollars out of that $10 widget by applying DE. But I wanted to take the example from the other part of our session today, the advanced manufacturing part of it. So at Aerojet Rocketdyne, we have seen an order of magnitude reduction in part counts by using additive manufacturing, for instance. So it's those kind of sea changes that DE really brings to the landscape on the entire design and sustainment lifecycle. So take that comparison of a 200 part assembly that you've brought to 20 parts with maybe just 3 welds when it used to have 50 welds. Take that same approach and take that $10 widget and tell your management that we're going to take maybe make that $10 widget a $5 widget, but more importantly, that widget that would have come in 2030, we're not going to give you in 2022 or 2023. So it's the time compression element of what DE does for a program that is the real value.
All right, thanks, Andy. Paul, you're up. So what has taken place in the training and culture development at your company to move the workforce into digital?
Yeah, so Rich, our investment in digital technology, digital engineering is front and center this year. And I say investment, I mean in all aspects of investment. I think it's important to remember, and maybe it goes without saying, but I'll say it anyway. Digital engineering is not a tools exercise. This is a significant evolution in our processes, in the way that we approach our problem space. And perhaps those processes are enabled by the advent of tools and common databases and the ability to share data. It's a cultural change, and we look to some of our earlier career folks who are perhaps more open-minded and more acclimated to what digital engineering brings and how those processes can be modified to fully utilize the advent of these tools and access to the data in a much more rich and comprehensive way. So we're certainly investing in the training, in the modification, the evolution of our engineering processes, our manufacturing processes, and our sustainment processes to really derive the value that digital engineering can bring. In terms of changing culture, it's we look for near-term wins. What are the pilot programs that we can look to and instantiate some of these tools and processes in whatever phase they may be in, highlight the value that is being derived and make that known and get people on board and really kind of develop a pull for digital engineering in all of its forms. And again, and then look for those signs of success. Too often I still see us talking about, digital engineering and how we're going to use it. Yet I still see signs of the legacy ways of running programs. Are we still?
Unfortunately, Paul, I'm going to have to cut you off right there because we only have about a minute and 10 seconds left, and I want to do some closing remarks. So thank you very much. In closing out this session, I feel it's fitting to use a quote that Dr. Roper used to conclude "There is no spoon." And that quote is, "This is what defense acquisition is waiting for, a new paradigm, a digital one, that can wake up to a new reality for both taxpayers and warfighters. Rather than just building better system, it builds systems better, opening doors to faster design, seamless assembly, and easier upgrades." These 2 days of mission domain engagements for digital engineering and advanced manufacturing have proven that our industry partners truly and proudly support the mission of the Department of Defense. We can't go back to the way things are done or we'll lose the fight. The continued cooperation and free-flowing exchange of data from industry to Air Force to industry, and industry to industry is vital. if we are going to maintain dominance in airspace and cyberspace. And like the Matrix-inspired document from Dr. Roper, it's time for us to wake up. I'd like to thank our panel of experts today, Paul Ferraro, Andy Kuhn, John Matlick, and Matt Tyshar for giving us their time and expert insights into how digital engineering is shaping the way we all do this business. And I hope everyone has a terrific rest of the day. This now concludes our panel.